Okay, today we're going to start working on lesson 4.5, or continue our work, I should say, on 4.5 on arithmetic sequences. The first part of this was getting to understand what sequences were, being able to identify them, and then you start using that explicit rule to be able to find some of them. Today we're going to start writing our own explicit rules and go through that process. Okay. So this says there's an arithmetic sequence below. Write the explicit formula for the nth term of the sequence. All right, so we're going to jump right in here and write the rules, or be able to write it. It's a formula, if you will, to generate whatever term of the sequence we want. So there's two things we have to know to be able to write a explicit rule for an arithmetic sequence. One is the common difference, your D, and the second one is your first term of your sequence. So those two things we can find right here by looking at it. Okay. We know our formula is a sub n equals a sub 1 plus d times n minus 1. So we need to know the first term of the sequence, and we need to know the common difference in order to be able to write this formula. And we got all that information right here. So we know, looking at this, our first term of our sequence is 26, and we know our common difference is minus 5. Okay, so we're going to subtract 5 or add a negative 5 each time. Those are the two pieces I needed. So I'm ready to write this explicit formula now. So what I'm going to do is I'm going to replace a sub 1 with 26. I'm going to replace d with negative 5. And we're ready to go. Now, what we'd like to do is simplify this. All right. Now there's what so we're gonna go ahead and take this negative 5 and distribute it through the parenthesis, and then simplify what's left so we can write the most basic statement we can. So if I distribute negative 5 through the parentheses, I'm going to get negative 5n plus 5. And then I want to combine my like terms. 26 and 5 are like terms. Negative 5n are not like these two. So I'm going to put those two together. We'd like to put the variable term first and the constant last. So it's going to be negative 5n plus 31. Okay. And again, if you remember me saying Friday that this arithmetic sequence concept fits right now, because when you graph it, it's a straight line. Well, this looks a whole lot like y equals mx plus b right here, because that's what it is. Okay. All right. Let's write another explicit formula or rule for this one. All right. So again, there's our formula. We need to know the first term of the sequence and common difference. First term of the sequence is negative 15. The common difference, you can see we're adding 8 each time. Okay, so go ahead and plug those two in. Negative 15 plus 8 times the quantity of n minus 1. And simplify. Distribute the 8 through. Combine like terms. Now I got negative 15 and negative 8 are like terms. So I'm going to wind up with 8n minus 23. There's our rule right there. Okay, to find any term in this sequence, if I want to find the 100th term, I'm going to put 100 in place of that n, 100 in place of that n, calculate my answer, and that would tell me what the 100th term would be in this list of a sequence. Okay, so that's how we write a explicit rule for the arithmetic sequence. Okay, this one's a little bit more direct here. It says find the 20th term of the sequence whose common difference is 4 and whose first term is 2. A sub 1 is 2. All right, well, again, here's our formula. To be able to write a formula, we need two things. First term of the sequence, common difference. So we have those two given to us. So a sub 1, first term of the sequence is 2, common difference is 4. Plug those in, simplify, distribute the 4 through, combine like terms, 4n minus 2. So there's our formula. This formula, this explicit rule, if you will find any term in the sequence just by substituting that in for n. So now they're saying find the 20th term of the sequence. All right. So we're going to take our rule. We're going to plug 20 in place of the n's and do the calculations. And if we were to continue this particular sequence out to 20 terms, the 20th one would be 78. Okay. Pretty straightforward there. All right. Find the 25th term of a sequence whose common difference is negative 3 and whose first term is 5. Okay, same kind of question. So now, again, always start with the formula. A sub 1 plus d times n minus 1. Plug in what we know. A sub 1 is 5. Common difference is negative 3. Okay, plug those in. Now this minus 3, I got to distribute with it, right? So it's got to be -3 times n and -3 times -1. So that's going to give me 5 minus 3n plus 3. Combine our like terms, and then we get a sub n equals -3n plus 8. So there's our simplified explicit rule for this particular sequence. Okay, now we got to apply it. It says find the 25th term. So a sub n equals -3n plus 8 is our rule. 25th term, put 25 in place of the n's. Okay, -75 plus 8, -67. So the 25th term in this arithmetic sequence is -67. All right. Okay, find the 80th term of this sequence. All right, so now they're not telling us the first term and the common difference, but we can find it by looking at it, and then we got to write a rule, and then we got to apply the rule. All right, so again, here's our formula. Always start with that. Now, first term of the sequence, 12. Common difference, it looks like we're adding 9. Plug those in. Okay, distribute our 9 through, combine our like terms. So our simplified explicit rule is a sub n equals 9n plus 3. Now, take our rule and find the 80th term. A sub 80 equals 9 times 80 plus 3, 720 plus 3. So if I was to carry this sequence out, adding 9, adding 9, adding 9, keep going, the 80th one is going to be the number 723. Okay? Same concept. Here's an arithmetic sequence. Find the 67th term. So we'll go ahead and follow our rules here. So a sub 1, okay, find a sub 1, find common difference. So a sub 1 is 15. Common difference is it looks like we're subtracting 9. Subtract 9, subtract 9. So our common difference is -9. Okay, so plug them in. Simplify, take our -9, distribute it through. Combine like terms. -9n plus 24 is our simplified rule. Okay, now use it. Take our rule and find the 67th term. Okay, so a sub n equals -9n plus 24. A sub 67, this replace our n's with 67. -603 plus 24. And we now know the 67th term of the sequence. So I carry this thing out. 67 to get to the 67th one, I should say. The answer is going to be -579. All right, so that's how we write explicit rules. Use the formula, find the information you need, plug it in, and then simplify it, and then use it. So it's pretty straightforward. You got the video there. Go back, write down any notes if you need them. The homework follows pretty closely from the lesson. All right, I'll let you get at it.